All right, so in this video, we're going to apply some of the stuff we've been doing. We're going to do a few examples. This is a module 4.4, or so module 4.4, using special distributions. The first one we're going to do is applying to jobs. So we're going to do an example of applying to jobs. In our where is it? Here we go. So in our eCampus, you have a file called Understanding and Choosing the Right Probability Distribution. So most things follow a special distribution. So in this case, applying to a job is going to be discrete. And we're going to say that for this, whenever we apply to a job, we're going to say each one is completely independent. So each application is completely independent from one another. And let's say the odds of getting an interview at one firm is exactly the same at all the others. These assumptions may not completely represent reality, but it's an okay example for now. So let's say first we got to pick and choose the right one. So it's going to be a binomial distribution. So for this, the binomial distribution describes the number of times a particular event occurs in a fixed number of trials. So in this case, each event, it's IID, independent, identically distributed. So each application follows the exact same binomial distribution with the same probability. And we want to know how many, or maybe how many you should apply to for some specific odd. So the conditions that must be met. Each trial has only two outcomes. So let's say the success. So there's two outcomes. Whenever you apply for a job, you send in your application, and you either get an interview, you either get a call to come in for an interview, or you don't. There's only two outcomes. You either interview or you don't. The success would be you interview. And let's assume that the trials are all independent. So all of the trials are independent from one another. What happens in the first trial does not affect the other. And the probability of an event occurring remains the same from trial to trial. So these are, we're going to assume that's IID, independent, identically distributed. So let's go back to our whiteboard. Then we can go over what we're going to be doing. So in this, we're going to apply to a job. So our example is applying to jobs. So let's assume every single job you apply to is completely independent. And let's say you're real confident, believe you just need at least one interview and you'll get a job. So we just need one interview and you get a job. Now let's say a question you may ask then would be, how many jobs do you need to apply to in order to have at least one, or at least to have a 60% of having one interview? Let's say X is our random variable. Let's say it follows a binomial distribution. It's going to be N, P. So N is the number of trials. P is the probability of a success. So let's say the probability of getting an interview for any one application, let's say P is equal to 2%. Excuse me. So P is equal to 2%. How many applications do you need to fill out in order to have a 60% likelihood of getting at least one interview? So we want to know N. We want to find N. How many jobs do you have to apply to in order to get an interview? So we want to know. We want to have a high probability of getting an interview. So you're confident. You think you just need at least one. So we want to know the probability of X being equal to or greater than 1. And this would be, remember, this is goes up to N. You don't want to add all that up. So let's say this is equal to the probability of X being less than 1. So 1 minus the probability of X being less than 1. This is discrete. You can't have half an interview. You can't have 1.5 interview. So if it's less than 1 and it's discrete, that means this would be the same as a 1 minus the probability of 0. So what was the original question? How many, you're confident, you think you only need one interview and you'll get a job. So let's say we want to know how many applications, how many applications should you fill out to have 60% probability, to have the probability of X being equal to or less than 1 to be at least 60%. So it's about 60%. So we want to know the probability of having at least one success. So let's do it. Let's solve. So I'm going to go back to our Python file, back to our notebook. So in here, we're going to import NumPy as NP, Pandas as PD, and we're going to, from our SciPy package, this comes with Jupyter Notebook, we're going to import stats. So stats is, if you go to the SciPy's website, you go to the statistical function, you see all the special distributions that they have. So under discrete distributions, we have Bernoulli, we have in binomial, we have there it is, binomial random, discrete random variables. So we have this built into SciPy. So I'll click it just so we can see some example code. And this is the formula for it. This is the same formula you'll see in here in the understanding and choosing the probability function. So anyway, so now from here we're going to import pyplot, Seaborn. You don't forget the magic command for matplotlib inline, and we're going to set the style to dark grid. So now we're going to go in and we're going to actually solve for it. So we want to know how many applications do you have to fill out to at least have to get one interview and to have a probability of at least 60%. So let's plot it out. Let's set our n. N is going to be a NumPy, and remember n is integer. So let's go from 0 to 101, because remember this is up to but not including 101. So it's going to be 0 to 100. Now let's say for our probabilities, let's say we want to find an n. Well, first we have to apply to at least one job to get one interview. So let's say stats dot our binomial function dot PMF. Let's say in this, let's actually look at the code to see what we're doing. Let's look at the inputs. So we're doing a binomial, we're doing a PMF, we're doing a probability mass function, and we have X. X is going to be our probability. So remember back what we're trying to do. We're trying to find the probability of 0, and we're going to apply to n many jobs. And we have, X is going to be the number. So we're trying to find 1 minus the probability of 0. So X is just going to be 0. N is going to be the number of applications that we fill out, and P is the probability of at least one of them being getting you an interview. So K is going to be 0. N is going to be N, and P is going to be 2%. Let's run it. Now let's look and see what we get. So I'm going to plot figure. I'm going to create a figure. Let's do fig size equal to 10 by 5. Let's do POT bar plot because it's discrete. X is going to be n, so the x-axis is going to be n. Height is going to be our probability. And let's just see what this looks like. So here we want a probability of 60%. So let's do let's plot a line. So let's do AX, axis H line, horizontal line. Let's give it 60%. Let's make it black so we can see it clearly. So this is where this intercepts here. This is going to be how many jobs you have to apply to at least have a 60% probability. So if you're getting confused, from this, remember what the binomial distribution is. So let's plot that out real quick. Let's say well, I don't want to even do that. Let's just look at here. So this is the binomial PMF. It's discrete. So this would be the probability of having K equals 0. As I say, you fill out four 4 applications or whatever it is, 4 things. N is 4. This is the probability of no successes, of 1 success, 2 successes, 3 successes, and 4. And the cumulative would just be the sum of all of those for that specific thing. So we're trying to find, in this case, we're trying to find the probability of 1 or greater, because we just need 1 interview and you think you'll get a job. So let's go over here. If we look at prob, this is going to be a NumPy array. We want to know how many do you have to apply to in order to have a 60% probability. So let's do greater than 0.6. You get a bunch of trues and falses. Let's close it up. And remember, this is Boolean array. And let's get the first element. So this is our probability. So if we apply to however many jobs, we would have a 60.5% probability of having at least 1 interview, which is what our main goal is. So let's plug it into our N array. So now we're saying if you apply to 46 jobs, you will have a probability of about 60.5%. Let's do this in 2 lines so we can see it. So N prob being greater than 0.6, get the first element. So if we apply to 46 jobs, we're saying you'll have a probability of 60.5%. So let's plug it in. Stats.binom.probability mass function. And we're going to say K is equal to 46. So K is the number of K is the number of successes. K is the number of successes. So let's say we want a 1 success, just 1 success equal 1. Really, we want 1 or greater. So let's say is 0, K equal to 0, N equal to 46, P equal to 0.02. And 1 minus this is going to give us 60.5%. So this would be the same as if we did stats.binom.pmf. If we did, so this is if we apply to 46 jobs, this would be the same as if we added up K equal 1 and K equal 2 all the way to K equal 46. To show this to you, we can do it. Let's do K equal to a NumPy a range from 0 to 47. I'm sorry, 47. And let's say prob is equal to K is going to be equal to K. N is going to be equal to 46. P is equal to 0.02. If I run this, graph it out, now we can do another plot. So let's do another bar plot. So then here the x-axis is N. Now the x-axis is going to be K. And our height is going to be prob. Again, we look at this. This is the probability of each of these. But if we add up all of this, so the probability of having at least 1 application would be this plus all the others. So if I add them all up, if I add up all of these and I sum them all up, we get 60.5% again, because we're adding up all of these K's. We're adding up K equal 1 all the way to K equal 46. So we applied to 46 jobs. We just want at least 1 interview. And if we do that, then we will have 60.5% probability. So this is applying to jobs. Let's say we change it up a little bit. Let's say you improve your resume. Let's say you improve your resume and you just need exactly 1 job. PMF. You just need exactly 1 success. Let's say you apply to 50 jobs and P is equal to 0.055%. This would be the probability of exactly one callback. let's let's change this up here. Let's repeat it. Or I'll do it here. Let's repeat this. If you want, so let's do the same thing. If you want at least a 60, or let's say if you apply to 50 jobs, just so it's an easier number, and let's say you improve your resume and you have a 5% probability. If you apply to 50 jobs and you apply to 50 jobs and you want at least one interview from that, now you have a 92.3% probability. So this is this would be the probability of applying to if you applied to 50 jobs, assuming that it's IID binomial. This would be the probability of having at least one interview. So if you want to improve your odds, you can only improve your probability so much. And if, say, the max you can get is 5%, the only way to improve your odds of getting a job application or to getting an interview would be to increase N. That would be the only way. So anyway, this is our applying to jobs example. This is in the PDF. The next one we'll do a coffee shop, and then after that we'll do a continuous example of portfolio returns.